Hello, everyone. Welcome back. Today, we're going to be talking about solving a system of equations when we have two quadratics. So, when we have two quadratics, it's possible there will be no solutions at all. It's also possible there will be one solution, and it's also possible there will be two solutions. However, there will never be three solutions or more than that. It's either going to be none, one, or two. We're also, in this case, when we're looking at it graphically, I want to point out we're only talking about real solutions because one could argue that every single one of these is really two solutions if we consider the complex solutions in the no solution one, and if we consider the one solution category as two separate ones because it's really one repeated, so that makes two. But in this case, we're really just looking at the real solutions and only distinct solutions as well. Okay, so let's go through some examples of solving these systems of equations. So I would say that for quadratics, when we have two quadratics, a pretty good strategy generally to do is to use substitution to get both of the quadratics in terms of y equals whatever y is equal to, whichever quadratic, and then use substitution, move everything to one of the sides, and then solve the quadratic that is remaining is generally a good strategy for this one. Now that said, we could also use elimination if we would prefer that, and that works as well. It's really going to be the same thing. And so for one of these, I will do substitution. For one, I'll do elimination, but it doesn't really matter. The only method that I think would be harder, especially if we don't have a graphing calculator, would be to do graphing, because oftentimes in practice with these, the solutions will be irrational. They won't always be, but sometimes they will be, in which case we'll only really be able to get an approximate solution by graphing, unless, of course, we have the graphing calculator and we're able to use that, which we aren't always for questions like this. Okay, so that all said, let's actually get into this example. That's probably why everyone's here, is to see this. So I'm first just going to rearrange this second equation here to get it in terms of y equals blah, blah, right? So y is equal to x squared minus 9. And then I'm going to sub the equations into one another. So we're going to end up with x squared minus 9 is equal to 2x squared plus 8x plus 5, because y is equal to the right and y is also equal to the left, so therefore left and right must equal each other as well. Then I'm going to move everything to the right, although it doesn't really matter which side, whether you move everything to the right or everything to the left. We just want to get something that's a little bit easier for us to solve. So I'm going to subtract x squared from both sides and also add 9 to both sides to get that 0 is equal to x squared plus 8x plus 14. Now at this point, we could try to see if we could factor this, or we could just use the quadratic formula. I will try quickly to factor this. However, if I can't figure out how to factor it right away, I will turn to the quadratic formula, because keep in mind, sometimes it isn't actually possible to factor. So in terms of what numbers multiply to 14, 1 times 14 does, 2 times 7 does, and that's really it. And neither of those combinations of two numbers would add up to 8, right? 1 plus 14 is 15, 2 plus 7 is 9, which is pretty close to 8, but still not quite right. And so I'm going to scrap the idea of factoring and just go straight to the quadratic formula here. All right, so for the quadratic formula, we know that a is equal to the coefficient of x squared, which is 1, b is equal to the coefficient of x, which is 8, and c is equal to the constant, which is 14. So therefore we have x is equal to negative b, right, negative 8, plus or minus the square root of 8 squared minus 4ac all over 2a. And that's going to be equal to negative 8 plus or minus the square root of 64 minus, let's see, what's 4 times 14? 56 all over 2. And that is going to give us negative 8 plus or minus the square root of 8 over 2. And that actually can be simplified a little bit further, a bit better here, because keep in mind that root 8 is the same as 2 root 2, right? Because 8 is the same as 4 times 2. Root 4 times root 2 is just the same as 2 root 2. So therefore, we're going to get negative 8 plus or minus 2 root 2 over 2. And that's going to be equal to negative 4, let's see, plus or minus root 2. Okay, so this one is clearly going to be an example where we have two solutions. So this would fall into this category here. And so it turns out the reason we weren't really able to factor it very easily is because we ended up with something irrational here, right? The odds of us figuring out that this was going to be the way to get there is very small, right? By doing guess and check. But now we know the x values. We know that the solutions are going to both involve x being either negative 4 plus root 2 or negative 4 minus root 2. So now we just need to plug these answers back into one of the original equations to find the y value here. So I'm going to use the second equation, the one where it says y equals x squared minus 9, just because I think that's an easier equation than the first one. However, of course, whichever one you use is completely fine, but I'm just going to take the path least resistance and plug it into the one that I feel is easiest. So y is equal to x squared minus 9, which in this case is going to be negative 4 plus root 2 squared minus 9. And that's for when x is equal to negative 4 plus root 2. And then y for when x is equal to negative 4 minus root 2 is going to be equal to negative 4 minus root 2 squared minus 9, like that. And then, of course, I'm going to put this into a nicer format, a simpler form here. But essentially, those are the answers. Okay, so for this one, we're going to, let's see, square the first, square the last, double the product. So we're going to get 16 plus 2 minus 8 root 2, because, double product, wonderful, okay. Minus 9, so that's going to be 18 minus 9 minus 8 root 2, which is going to be 9 minus 8 root 2. So that's the answer for that first one. So one of the solutions, in other words, is x is equal to negative 4 plus root 2, and y is equal to 9 minus 8 root 2. So that's one of the solutions for this. Of course, there's a second one we have to figure out still. And then for the second one, we have 16 plus 2 plus 8 root 2 minus 9, which is equal to, let's see, 9 plus 8 root 2. There we go. Okay, so the second solution, therefore, would be negative 4 minus root 2 for x, and then for y, we got 9 plus 8 root 2. Well, let's write that a bit better. 9 plus 8 root 2. And there we go. Those are the solutions for A.